Okay, and if you do not know what that conversion factor is, you need to find someone who does. Does anyone need to go and ask someone today? So I could, in theory, call upon any one of you to give me this conversion factor. I could randomly search through my list and pick a name. If you don't know what it is, go find someone who does. So if you get called on, you won't be like, I don't know. Go ask someone. Lots of people around. Okay, in our conversion factor, we have the number 1. What's the other number that we have on the other side of the conversion factor? 6.02 times 10 to the 23. Now, if you have trouble remembering the power of 10, once again, it's as easy as 1, 2, 3. Look at that. Isn't that nice? Yes. Okay, so what are the units that go on each side of this conversion factor? Mole. Where does the mole go? Goes with the 1 mole. And so it's going to be 1 mole of things, whatever those things may be, is equal to 6.02 times 10 to the 23 things. Now, mostly these are particles, atoms or molecules. Because they're really the only things that are small enough that we have to count them in such large units. Yes? And can you think of another number that's much smaller that we can count in that is a similar sort of a thing? If I had 12 things, yeah, that would be 1 dozen things. Yes? So a mole is a number very much like a dozen is a number. It's just a dozen is easy to visualize. A mole is difficult to visualize. Now, you remember when we were doing conversion factors, the 1 went with the prefix. Hello, can I help you? Oh yeah, that's fine. So we have, let's see, where did I get to in my brain? I don't know. Nope, don't know what I was going to say. It's all good. Okay. So, there. Okay. We have a second conversion factor, and we did learn it yesterday. I don't think in this block that I gave it a name, but I did in my other 2 blocks, and it is called, this is the first one, this is the second one. It's called the particle ratio. Particle ratio. And it is the ratio of the number of atoms in 1 molecule. Do you remember we did that last day? And you counted a bunch of things for homework? Yes? Okay, so it could be the number of atoms per molecule. It could be, and we're going to do this one today, it could be the number of ions in a formula unit. And it could be the number of atoms of A to the number of atoms of B. Basically, it's comparing one type of particle to a different type of particle, and you will use the chemical formula to count the atoms or ions or whatever. Is good? Okay, so we now have two conversion factors, and let's take us to this page here. This is mole summary number 1. This has like everything on it. So if you made it to the end of section 5.4, it doesn't have 5.5, that's a separate topic. But if you make it to the end of section 5.4, you will have done all of this. We have so far covered converting from moles to atoms. Now, if I'm going to convert directly from moles to atoms, I would need to be starting with moles of atoms. Yes? I can also convert from moles, that's not a highlight. I can also convert from moles, come on, there we go, to molecules, because remember we can convert between moles and particles. Atoms are particles, molecules are particles. But if I'm converting from moles to molecules, I need to be starting with the moles of molecules. Does that make sense? It's like if I had a dozen elephants, I can find the number of elephants. I cannot find the number of ducks. Yes? So if I'm going from moles and I want to find atoms, I have to be starting with moles of atoms. Yeah? And the second conversion factor that we've learned, so this is the one where we have 6.02 times 10 to the 23 atoms per moles of atoms, or 6.02 times 10 to the 23 molecules per mole of molecules. If I gave you, let's say I gave you H2O molecules, you could find, let's say I gave you the moles of H2O molecules, you could find the number of H2O molecules, right? We start with moles of molecules and then we convert to the actual number of molecules. From there, I could find the number of hydrogen atoms, because there are 2 hydrogen atoms in every 1 molecule. So that would be a 2-step problem. Okay, we're going to go over this again and again. This right here, that is the particle ratio. And if you're wondering where this page is, it's 5.0a. It is at the very front of your book. Okay. So that's what we're going to be focusing on for this first little bit, is this left-hand side going horizontally. Okay, so all the way from the moles of molecules over to the number of atoms. And later on this week, probably on Friday, but for you guys, it won't be Friday, it'll be the weekend, because you have to walk during class. So you get extra homework for the weekend. I am so sorry. We're going to be doing this on Friday, okay? So we'll get the whole horizontal bit going. In the short term, that's what we're doing. Let's see, is there anything else here? This is sort of a simplified chart. This is on the next page. You can see you have moles of A can only be converted into particles of A. So if you have a dozen eggs, you can only find the number of eggs. Okay, so if I have moles of water, I can only find the number of water molecules. If I have moles of carbon, I can only find the number of carbon atoms. okay? Then if I want to convert between those particular particles and a different kind of particle, I would have to use the particle ratio. I kind of like this sheet because it sort of breaks things down a little, like it makes it more simple just to look at, but it also doesn't give you as much detail. For example, it just says Avogadro's number is used to convert between those two. Whereas on the previous one, it tells you that Avogadro's number is, what's Avogadro's number? 6.02 times 10 to the 23 atoms per 1 mole. So let us go, where are we at now? We did that, we are here. Let's just do a quick little look at page 16. Thank you. Recall that a formula unit is like a molecule. Okay, these two are similar. It's like, this is page 14, I think. 16, page 16, sorry. It's like a molecule, but for an ionic compound. So it is a single unit of an ionic compound. Thank you. Now remember, ionic compounds do not exist as molecules per se, because they go on and on in 3 dimensions in a crystal lattice. Okay? So let's take an ionic crystal lattice. So here we have calcium phosphate. Calcium is 2+, phosphate is 3-. So hopefully by this point you know that we need to make the total positive and total negative equal how much? 6, right? Because that's the lowest common multiple of 2 and 3. It's okay. So we would need to have 3 calciums to give us 6 positive, and we would need to have 2 phosphates to give us 3 negative, which means that our formula then is Ca3PO4 2, and that is our formula unit. And if you wanted to look at what that looks like, we would have a calcium and a calcium and a calcium, and we would have a phosphate and a phosphate, so just 2 phosphates. How many calcium ions are there in one formula unit of calcium phosphate? Tell your partner, how many calcium ions in one formula unit of calcium phosphate? And this is a formula unit of calcium phosphate. How many calcium ions? How many? It's not hard. Everybody, how many? 3, right? We have 1, 2, 3 calcium ions. So we have our 3 calcium ions. Let's write this as a conversion factor. We have 3 calcium ions per 1 Ca3PO4. And there is something wrong with what I've written. See if you can figure it out. Brackets? Yeah, actually, don't need brackets here, but I do need something else. I could put formula unit. It's actually almost like you don't really have to put the formula unit. You could just say CO3PO4s and leave it at that, okay? But you could put formula units. But there's something missing from the top. The charge. You cannot write calcium ions without saying Ca2+ ions. Remember the charge. And you could also write this flipped upside down. So we could have 1 Ca3. Oh, I know what brackets and charge you were talking about. I made another mistake. The one that I didn't know that I had made. We need 2 PO4s. So we need brackets in the you knew exactly what you were doing. Okay, Ca3, PO4, 2 per 3 calcium 2+ ions. There we go. So if we have 16 formula units of Ca3PO4, so we are starting with 16 Ca3PO4 formula units. Am I going to use version A or version B of the conversion factor? I want B because calcium phosphate has to be on the bottom. Ca3, PO4, 2 formula units. We have one of those for every 3 calciums. And that is equal to, I believe it is 48. Yes, it is. 48 Ca2+ ions. How many phosphate ions are in one formula unit of Ca3PO42? 2. And let's write this as a conversion factor. Where's the charge? Yeah, where is the charge? I should have written a charge with my ion. Anytime you have an ion, don't forget the charge. So now in our question, if you start with 18 PO4 ions, that is our initial quantity, how many formula units of calcium phosphate, that is our unknown. So this is our unknown, which is equal to our initial quantity, 18 PO4 3- ions, times the conversion factor, can I use the conversion factor in the form that it is here? In yellow. No, I need to flip it upside down. Okay, so I'm going to put the 2 PO4 3- ions on the bottom and the 1 Ca3 PO4 2 on the top. 18 divided by 2 is 9. PO4 3 minus ions cancel out, and we're left with 9Ca3 PO4 2, and those are formula units. Now, if you were to call those molecules, I would not get mad at you. Okay? So if you didn't call them formula units and you're like, molecule, close enough, I'll be like, okay, it's all right. Yes? Okay. Could you please write a conversion factor between calcium ions and phosphate ions? Hmm? Yeah, that's great. Thank you. Is good? No, I need my charges. You got all the sign language down. I love it. 3 minus. There we go. Hmm? Oh, and my numbers are wrong. My numbers are wrong. Oh my gosh. I didn't even do that one on purpose. That's just my brain going, eh. Okay. Could you, I would like you to try writing out the work, and then we'll check your work to see that you'll get full credit. Okay, so you go ahead. How many phosphate ions would it take to react completely with 6 calcium ions to form calcium phosphate? So check your work. Did you show what you were trying to find? Did you show your initial quantity, including the charge? Did you show an equal sign? Oh. Did you show a time sign? I know it seems silly, but people will write equal signs in between. Their brain just goes kaflooey, because mine never does that. Okay. Did you write your conversion factors with the charges? And did you, should probably cancel those out. And then your final answer, you should probably box it. Okay? Do you see how we're now combining units 1, 2, and 3? And 4? Now, you can also convert between formula units and atoms. I don't feel like we need to go through this. It's more of the same. Would you like to go through it? No. Okay, so we're not going to go through that. I will leave that for another time. Here we go. This is, in fact, I'm not going to do this one either. This is going to be for homework. This is converting either atoms and molecules and ions and formula units. We'll just leave that one. These are sort of randomized, okay? For now, we are going to go to page 20. And we're going to have two-step problems. The two conversion factors are the two that we listed earlier today. We have conversion factor number 1, which is Avogadro's number, which is 1 mole of particles equals 6.02 times 10 to the 23 particles. And we have conversion factor B, where we can convert from the number of atoms or ions to the number of molecules or formula units like we were just doing. And there is a map here if you want to use it. Will you get this map on a quiz or a test? No. Basically, if you know your conversion factors, you should be able to say, if I know this conversion factor, I can go from this to that. If I know the number of water molecules, I can find the moles of water molecules, for example. Yes? Let's do one of these together. How many O atoms, so that's our unknown, are in 3.00 moles of sodium phosphate? That is our initial quantity. So we are starting with 3.000 moles of Na3PO4. I'm going to highlight that in yellow because we're dealing with Na3PO4. Can I turn moles of Na3PO4 directly into the number of oxygen atoms? No. I can only turn moles of Na3PO4 into the number of what? Na3PO4. It's like if I had a dozen bicycles. I could go from 3 dozen bicycles to 36 bicycles, but I would have to go an extra step if I wanted to know how many wheels there were, right? And multiply by 2. So we can go from Na3PO4 to number of Na3PO4, and from there we can use the particle ratio to go to the number of oxygen atoms. So here, from moles to particles, this is Avogadro's number. And when we're going from one type of particle to a different type of particle, that is the particle ratio. So let's write down what we are solving for. We are trying to find the number of O atoms. How many O atoms do we have? Well, we are starting with 3.000 moles. Now remember, the abbreviation for mole is MOL. We take off that one letter and we've shortened it so much. Okay, so mole is abbreviated as MOL, so it just means the same thing. So we have 3.00 moles, and you never write moles without saying what you have moles of. Okay, so we have moles of, I don't actually write the word of, but I do write Na3PO4. Okay. And in order to go from moles to the number of things, I need to cancel moles of Na3PO4, so I need to put that down here. And I need to put the number of Na3PO4 up here, so this is Na3PO4 PO4, and you can put formula units in there if you wish to, okay? If you put molecules, that would also be okay. What numbers go in there? Tell your partner what number is going to go on the top, what number is going to go on the bottom. What number is going to go on the top? What number is going to go on the bottom? There's going to be a number 1. Where does the 1 go? On the top or the bottom? On the bottom. That's like saying 1 dozen eggs. Yes? Now, the number that goes on the top is 6.02 times 10 to the what? 23, 10 to the 23, Na3PO4. Now you can do this in 2 lines. If you wanted to put an equal sign, you could do that, or we could do our second step in 1 line. We want to go now from Na3PO4 to O atoms. So let's cancel our Na3PO4 and let's find O atoms. Tell your partner what number goes on the top and what number goes on the bottom. What number goes on the top? 4. There are 4 O atoms, right? 4 O atoms in 1 Na3PO4. And that's actually really nice. You just count them up using the formula, okay? And we get 3 times 6.02E23 times 4 equals, and we have 7.224 times 10 to the 24. Let's check out our significant figures. How many sig figs should we have in our answer? Tell your partner. You want to hold up the number of fingers for your number of sig figs? If you're not sure, you can go like this. And if we're not sitting there not voting, what are we doing? You either don't know, you have a number. What number? Go. Yes, it is 3. And if you don't know why, let's take a look. We have, let's maybe use a green highlighter here for our sig figs. We have 4 sig figs here, yes. And we have 3 sig figs here. That number 6.02 has 3 sig figs. We could actually give it as 6.022 times 10 to the 23. That's what they use in AP chemistry, but it's not what's used in most of the grade 11 books, so I've decided to stick with the 3 sig fig version. Now, what about these guys over here? They have infinite sig figs because we're counting. There are literally exactly 4 oxygens in one of those particles. That's not approximate, okay? So these are exact, therefore they have infinite sig figs. This one has 3 sig figs, this one has 4 sig figs. So we round our answer to the smaller number of sig figs. So that's then going to become 7.22 times 10 to the 24. Let's not forget our unit. We go back and it is O atoms. Is good? Excellent. Would we like to do one more example of this kind? Yes or no? Yes? Okay. Let's do one more example of this type where we have 2 conversions. In fact, let's see. Oh yeah, I'm going to do number 3. Okay. How many moles of dinitrogen tetroxide? What is the formula for dinitrogen tetroxide? N2O4. That's what we want to figure out. Can we make from 1.204 times 10 to the 24 O atoms? Can I go directly from O atoms to moles of a different substance? No. Because I have moles of N2O4, I actually need the number of N2O4s. What conversion factor will we use to go between the number of O atoms and the number of N2O4s? That's the particle ratio. Just look at your formula and count them up. And what conversion will I use to go between the number of N2O4 and the moles of N2O4? Avogadro's number. So our unknown, how many moles of N2O4, is equal to our initial quantity, which is this one, 1.204 times 10 to the 24 O atoms. And I have 2 steps. Yes, I got one conversion here and I got one conversion here. So I'm going to have 2 conversion factors. Okay. And I want to convert between O atoms. So I need to cancel O atoms. And in my first step, I am finding the number of N2O4. So on the top, I'm going to put N2O4. Please tell your partner what numbers go in there. What number goes on the top? Which one goes on the bottom? One goes on the top and 4 goes on the bottom because we have 4 O atoms. 4 O atoms in every one N2O4. We're going from the number of N2O4s to the moles of N2O4. So let's put N2O4 down here and moles of N2O4 up on the top. Tell your partner, where does the 6.02 times 10 to the 23 go? Does it go on the top or the bottom? And how do you know? The 1 goes on the, or sorry, the 6.02 goes on, times 10 to the 23 goes on the bottom. When in doubt, the 1 goes with the mole. Now, if you have problems remembering that, because you're like, I asked someone this morning, I'm like, where does the 1 go? And they said, with the prefix. And I'm like, okay, but there's no prefix here. So you can still do the little song, but now I want you to imagine some little moles, like this little guy here, okay? And they're doing the conga. The 1 goes with the mole, the 1 goes with the mole, the 1 goes with the mole, okay? It's not as good, but if you picture little moles, I want you to close your eyes and imagine a line of moles going along, doing the conga. The 1 goes with the mole, 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 and that's going to work for most mole conversion factors. Not all of them, but a lot of them, okay? So if you're in doubt, put the 1 with the mole. Where did we get to? Oh, here we are. Okay, so now we have done our 2-step conversion. We have 1.204 times 10 to the 24 divided by 4 divided by 6.02 times 10 to the 23 equals 0.5 moles of N2O4. How are we feeling about that? There are always going to be 2 steps. One of the steps is going to, in this worksheet, one of them is going to be the particle ratio, one of them is going to be Avogadro's number. All right? So let's see what I would like to assign you. First of all, if you have not yet handed in your lab, please hand in the lab. If you need another day for your lab, please let me know. I know there's a couple of people who got the stuff late or whatever. A whole extra day to do the conclusion? Okay, okay, okay. Yep, no worries. What? Okay. Yeah. I would like them handed in by tomorrow so you don't have it hanging over your head for your test. Yes, so if you've not handed it in today, please make sure it's handed in tomorrow. 2, we're gonna do, let's see. (3.1g) numbers 1 through 4. I'll write it up here. I'm going to leave up yesterday's homework in case you didn't do it. Okay. Numbers 1 through 4. Or I mean 5.1g. 5.1g. This is not on the test, no. So I'm not going to give you too many questions from here, because the rest of your homework is going to be study for your test, right? Page 21 to 22, number 2 to 6. So that is pages 21, 22. 5.1G was pages. Oh no, we're not going to do 1 to 4, we're going to do 1, 3, 5. There we go. And don't forget, on your test, there will also be some chromatography questions, and there will be some hydrate questions. So you need to study those, okay? Yes? You have not gotten your hydrate lab back. However, I have posted the lab itself on the test page where, let's see where it is. I don't have you doing a calculation for the hydrate. Okay, it's more about the theory behind the hydrate. So you can read about that 2 places. One of them is on Teams. If we go to our class, please go to our class. There we go. Oh yeah, help yourself. You can take the whole thing. Yeah. It should be HClO2. Yes, you're absolutely correct. Yeah. And let's go to upcoming quizzes and tests. And there's the hydrate lab. So if you open that up, the theory is on the first page, okay? So there's the theory. Anything that says mole, you don't need to know about at this point, okay? But you should understand the general idea of the hydrate. The other place to look is in your green workbook, in the section on hydrates, and it looks like you have that page open. What page is that? Page 87, okay, in your green book, okay?